Quantum computing is one of the most exciting areas of research in all of science today. And like most areas of science today, it's highly technical and difficult to understand. But at its heart, it's really about asking some very simple questions. Questions like, what is the nature of reality? What is the relationship between the observer and the observed? And what is the origin of the universe? These are the big questions that have kept philosophers awake at night for centuries. But now quantum computers are allowing us to answer these questions by simulating reality itself. Let me explain. Quantum computing harnesses the power of quantum mechanics to perform calculations in ways that are impossible for even the most advanced classical computers. This means that quantum computers can solve problems that are currently intractable, such as breaking some encryption algorithms or finding the optimal solution to complex problems like traffic flow or drug discovery. At the heart of this technology are qubits, which are the quantum version of bits. A classical bit is either a 0 or a 1. But a qubit can be both 0 and 1 at the same time. This may sound strange, but it's simply because our classical intuition about the nature of reality doesn't apply to the quantum world. In the quantum world, things exist in a superposition of states until they are measured. And the act of measurement itself causes the collapse of the wave function and the state of the system to be decided. This may seem like a small distinction, but it has profound implications. It means that we can use qubits to simulate any physical system, including reality itself. By harnessing the power of quantum mechanics, we can simulate reality on a quantum computer and answer some of the deepest questions that have kept humanity awake at night for millennia. For example, we can use quantum computers to model the behavior of subatomic particles such as electrons and protons. We can also use them to simulate the behavior of larger systems such as molecules and materials. By understanding how matter behaves at the subatomic level, we can develop new materials with properties that we desire, such as superconductivity or the ability to absorb carbon dioxide from the atmosphere. But perhaps even more exciting is the prospect of using quantum computers to simulate human consciousness. Some researchers believe that the key to understanding consciousness lies in the behavior of single atoms and molecules. By simulating the behavior of these tiny particles on a quantum computer, we may be able to unlock the secrets of the human mind. Of course, this is just speculation at this point. But the fact that it's even possible is a testament to the incredible power of quantum computing. So the next time you look around, remember that there's a whole other world of colors all around you that you can't see. And maybe someday we'll be able to use quantum computers to see those colors, too. It may not happen in your lifetime, but if you're patient enough, you might get to see it one day. The same goes for the other color. It's inside you and you don't even know it. That's right. You have quantum computers inside you right now. They're called neurons. And the way they work is still a mystery to scientists. But as we learn more about the brain, we're beginning to realize that it's not just a biological machine, but a quantum machine. Neurons use quantum effects to store and process information, which allows us to do things like make plans, solve problems, and even dream. We're only just beginning to scratch the surface of this vast inner universe, but who knows what wonders we'll find inside. So keep looking up at the stars and keep looking inward, too. The answers to some of the deepest questions about reality may be closer than we think. If you liked this video, check out my other content where I talk about all sorts of cool stuff related to science, technology, historical events, black issues, current events, and a host of other topics. Thanks for watching, and I'll see you in the next one.